Okay. So here we've got this week's specimen homework about circles. It's about time we got round to having a circles homework. Question 1. The points A and B have coordinates -2, 2 and 6, 8 respectively. C is the midpoint of AB. Find the coordinates of C and so on. So actually this is just looking back to the straight line graph stuff that we did and some of the things we learnt about there. If we've got 2 points and we want to find midpoint, then what's the easiest way of thinking about what we do with this? What do we do to find the midpoint of AB? Anyone? Go on, John.
Y1 plus Y2 over 2 and X1 plus X1. X2 over 2.
We just add together the respective coordinates and divide by 2, you're right. We probably do them in the order that we normally write them, so X and then Y. But that would give us a point. What is that? That's 2 and 5. There we go. And that's for 2 marks. They're the coordinates of C. The gradient of AB. Okay? So B, the gradient of AB, that's, again, this is just on your poster. One of the formulas that you've learned. So what's the gradient? How do you remember the gradient? Okay, so the change in y over the change in x. So y2 minus y1 over x2 minus x1. We've got to remember to get y on the top. So the change in the y value is 8 minus 2 over the change in the x values. 6 take away -2 gives us 6 over 8 or 3/4 as our gradient. And finally, part C, the equation of the perpendicular bisector of AB. Well, what does this bit here tell us? What does it mean when we ask about the perpendicular bisector? What are we looking for? We need go on, Danielle, what are you going to say? It's the negative reciprocal of the gradient, isn't it? We need the line that's perpendicular to it. So our bisector is going to go through the point C, and its gradient is going to be the negative reciprocal of the gradient of the line AB. So it's going to be -4/3. We then use another formula that's on our poster that says y minus y1 is mx minus x1, and sub these values in. Y take away 5 is -4/3 of x take 2. Notice this question was asking us for it in the form ax plus by plus c is 0, where a, b and c are integers. So this -4/3 is no good. We're going to multiply both sides by the 3, which should leave it looking like that. Let's get rid of that bracket as well. And then it did want everything on one side, did it? Yeah. So we finally need to take everything over here. 4x plus 3y, we've got -15, take away another 8, gives us -23, is equal to 0. And that is that for the 3 marks at the end there. All good? Great, so we're ready to move on to question 2. Here's question 2. A circle. Circle has equation x squared plus y squared minus 6x plus 10y plus 9 is 0. Express the equation in the form that we're given there. Right, well, we looked at various ways of actually going through the process of doing this. Remember, the key thing we need to do is we need to think of this as being the x bits and the y bits and that number there as well. And I think the method that we finally settled on for this was we're going to just look at completing the square on this. X squared minus 6x, well, a half of 6 is -3, so that's x minus 3 squared. We would then get an extra 9 from multiplying it out, so we need to take away 9. And the other one is y squared plus 10y. Half of 10 is 5. Squaring that would give us an extra 25, so we need to take that 25 away as well. If we combine what we've just done here, the green bit leaves us with x minus 3 all squared minus 9. The red bit, replacing that, leaves us with y plus 5 all squared minus 25. We already had a plus 9 there, equals 0. And if we now throw all the numbers over to the other side, we've got x minus 3 squared plus y plus 5 squared is 25, because the 9 has cancelled itself out. And that's great. That was 3 marks, which leads us into 2 bits of information for part B. Write down the centre of the circle. Well, now we've got it in this form, we can read it straight from here. So what is the centre of the circle? 3 minus 5. And what is the radius? What's the radius, Molly? 5 square root of 25, so 5. Brilliant. We're next told that the point D has coordinates 7 minus 2. Verify that the point D lies on the circle. You know, we've got to be careful with this. This is only 1 mark, and I don't really like this. Doing it this way, I feel slightly uncomfortable doing it. But for 1 mark, it's all that we need to do is to sub these values in and check it gives us the right amount. So we sub these values in and do 7 minus 3 squared plus minus 2 plus 5 squared. We want to check that that equals 25. That is 4 squared plus 3 squared, which does equals 25, so D is on the circle. And for 1 mark, we don't want any more than that. The person who likes maths in me feels that I don't really like that way of doing it. What I would rather have done is do 7 minus 3 squared plus y plus 5 squared equals 25, and solve that for y and do it that way. But for 1 mark, that's enough. Ben, go on.
You're allowed to put it into the first equation and show that it equals 0.
You're allowed to put it in the first equation and show it equals 0 as well. Either one would be okay. Part 2. Find an equation for the tangent of the circle at the point D, giving your answer in that form. Right, well, this is all about using our circle geometry and understanding how things work here. The circle, there it is. It has a centre, what was the centre? Of 3 minus 5. There is the point 3 minus 5. There is a point on the edge of the circle at 7 minus 2, so over here somewhere. That's the point D. And the question wants us to find the tangent to the circle at that point. The tangent to the circle at that point looks like that, doesn't it? What we know is that if we were to join up that point to that point, it would leave us with a right angle there. And that's the crucial thing here. So we've got a point that lies on this tangent. We need to know its gradient. If we find a gradient of CD, then the gradient of CD is change in y over change in x, remembering to get these the right way around. That gives us, what does that give us? 3 over 4. So we're interested in the perpendicular gradient, because that's that one. So we want the tangent gradient to be the negative reciprocal of that, so minus 4/3. Turn the fraction upside down and change the sign. And now we can put it into our formula for a straight line. It goes through D, it has a gradient of minus 4/3, so it's y minus y1 is m x minus x1. we've actually ended up with a very similar equation to deal with as to in the previous question, but as in the last one, we need integer coefficients. So we've got, what have we got? If I times by 3, we've got 3y plus 6, that's plus 2 times the 3 is 6. And we've got minus 4x minus 7, so that's 3y plus 6 is minus 4x plus 28. So 4x plus 3y minus 22 is equal to 0. Let's just make absolutely certain. That does go through the point D, doesn't it? 28, take away 6, take away 22 is 0, so we're really happy with that. There it is. And that's maths.
Yeah.